So in this video, we're going to finish up the notes for section 14.1. So example 4 says the manager at a coffee shop counted the customers once each hour over a few busy weekends. The results she obtained are summarized in the bar graph to the right, and we're going to use the bar graph to answer a few questions. So part A says, what was the largest number of customers in the coffee shop and how often did it occur? So we notice this is a two-part question. Part 1, what was the largest number of customers? Part 2, how often did it occur? So when we look at the bar graph, we can notice on the horizontal axis, that's the number of customers that they found to be in the store as they took count over the course of the weekends. And on the vertical axis is the frequencies. So how often did they find that particular number of customers to be present in the store? So if we're looking for the largest number of customers, we can see over the course of the weekends when they counted how many people were in the store each hour, the maximum number of customers that were ever in the store at a given time is going to be 12. And if we want to think about how often did that happen, we want to look at the frequency. So what we can do is just go ahead and figure out what is the frequency for each of these different classifications. Because there are some other parts of this question where we're going to be needing to utilize that information. So there were 12 times where they found no customers to be present. There were 9 times they found 1 customer to be present. 3 times there were only 2 customers. There was never a time where there were only 3. There was 1 instance of having 4, 7 instances of having 5, 10 instances of having 6, 9 instances of having 7, 6 instances of having 8, 5 instances of having 9. There was never a time where there were 10 customers. 1 instance of having 11 and 1 instance of having 12. So the largest number was 12. This occurred 1 time. Part B says, what was the most frequently occurring non-zero customer count? So if we look at this, they say the most frequently non-zero, because if we look at the frequency, the most frequent response was that there was nobody in the store or in the coffee shop. So when we look at taking that off of the table and look at everything from 1 customer up to 12, we find that the biggest or most common frequency was having 6. So the most frequently occurring non-zero customer count was 6. And if we look at the frequency, this happened 10 times. Part C, for how many hours were the customers counted? So in order to figure out how many hours they were collecting data over the course of these busy weekends, we are going to need to utilize the frequencies, because the frequencies are how many times there was nobody in the store, how many times there were 5 people in the store, how many times there were 12 people in the store. So to get the total number of hours that data was taken for, we add all of those frequencies together. 12 plus 9 plus 3 plus 0 plus 1 plus 7 plus 10 plus 9 plus 6 plus 5 plus 0 plus 1 plus 1 Once we add all of those together, we find that they took data for a total of 64 hours over those weekends. Okay, and then the last part of the question that we have connecting back to this bar graph says, for what fractional part of the total number of hours were there more than 6 customers in the coffee shop? Okay, so we know if we're thinking about more than 6 customers, that's when we're going to have 7, 8, 9, 10, 11, and 12 customers present. So in order to get the fractional part of this, what we're going to do is take the frequency for all of those instances. So the frequency for 7, 8, 9, 10, 11, and 12, we're going to add all of these up, and then we're going to divide it by the total number of hours, because that's what we want to know. What is the fractional part, the total number of hours? So when we do that, 9 plus 6 plus 5 plus 0 plus 1 plus 1 over 64. So that ends up being 22 over 64. And that fraction can be reduced down to 11 over 32. So it does ask what is the fractional part, so we are going to leave our answer as this simplified reduced fraction. So the last question we have in this section gives us some more bar graphs to compare. And it says the accompanied bar graphs compare women's and men's hourly wages in a recent year. So we want to know, in what age and wage category do women and men seem to be most equal? Okay. So if we kind of compare, we've got these 3 different instances. We're looking for where is the time where the bars between the men and the women are almost the same distance away from the far left. Okay, so we can see there is a pretty big distinction and difference between this first set here. So it's not going to be anything in that first graph. There's a little bit of a similarity in the last graph in this range, but again, for the most part, it's pretty spread. And if we just look collectively, we're looking at, well, the age and the wage category. So we can see that the wage does appear to be kind of even in that 20 to 24 age in all 3 instances. Those are pretty even. But we notice it's the most even right here in the middle when we compare those that are earning $9.51 to $12.49 per hour. So women and men seem to be equal, or to be most equal. For ages 20 to 24, earning $9.51 to $12.49 per hour. So that concludes section 14.1.